In this lab, management wants us to use BGP to exchange routes between two autonomous system networks. Specifically, management wants us to exchange routes between autonomous system 65500 and 65501. Like OSPF, BGP shares routes and chooses the best path to the destination for data packets. But let's focus on what makes BGP different. OSPF is a routing protocol used within a single organization or network. It optimizes internal traffic and routing, responds quickly to network changes, and is used for enterprise or internet service provider networks. BGP, on the other hand, is a routing protocol used between different organizations and internet service providers. It optimizes traffic flow across the whole internet, provides stable long-term routing, and is used for global internet routing. So essentially, OSPF is routing within one network or one autonomous system, and BGP is for routing throughout multiple networks or throughout different autonomous systems, which is why BGP is used for the internet. So let's start with router 1 in autonomous system 65500. Let's use PC1 to console in. Now remember, we determined some very specific steps to set up BGP. We need to know three things: the AS number, which we know is AS65500, the IP address of the interface on the neighboring router that our router is connected to, which in this case is 12.0.0.2. Then we need to know what routes we want to advertise from our list of routes, which we can see from the show IP route command. In this case, management wants us to advertise all connected routes, so instead of writing each one, we can use the redistribute connected command to automatically have all the connected routes advertised. So let's see what our configuration looks like so far. We got router BGP 65500 to say we're in autonomous system 65500 and we want to go into BGP configuration mode. Neighbor 12.0.0.2 remote-AS 65501, which tells the configuration that we're connecting to another autonomous system, remote autonomous system, which is numbered 65501 through router 2's 12.0.0.2 interface. And then redistribute connected, which tells the protocol to advertise all the connected routes on this router to AS65501. Save your configuration and update your notes. Now onto router 2, an autonomous system 65501. In this router, we're following the same three steps. First step, enter the router BGP autonomous system number. Then write the IP address of the neighboring interface and its autonomous system number. Notice the log already tells you that the neighbor BGP is now up and sharing. And lastly, we want to redistribute all the connected routes, so use the redistribute connected command. Remember to save your configuration. Now let's take a look at some of the troubleshooting and verification commands for BGP. Show IP BGP summary gives you a summarized view of the BGP configurations. From here, you can see information about the neighbor entries. Neighbor is the IP address of the BGP neighbor. V is the version, so the BGP version that the neighbor is using. AS is the autonomous system number of the neighbor. Message received and message sent are the total number of messages received and sent to the neighbor. Table version is the version of the routing table that the neighbor is using. The number increases anytime there are changes in the routing table. In queue and out queue are the number of messages in the input and output queues. Up down is the amount of time that the peering session has been established. And state prefix record are the state of the peering session and the number of prefixes or networks received from the neighbor, which is 4 here. That means we received 4 routes from this neighbor. The show IP BGP command shows us more information about the BGP routing table. Here we can see the status codes for each route, which shows us if a route is valid. We can also see the next hop for each route. If the next hop is 0.0.0.0, that means the destination can be reached via this router itself and doesn't need a next hop. Then we can also see which routes are the best routes. And and whether the routes are internal or not. Finally, we have Show IP BGP Neighbors, which provides more information on the neighbor relationship and status. BGP Neighbor shows the IP address and AS number of the BGP neighbor. For example, BGP neighbor is 12.0.0.1, remote autonomous system 65500, external link, which means that the neighbor is in a different autonomous system 65500 and is an external peer. BGP state shows the current state of the BGP session with the neighbor. For example, BGP state equals established here, up for 14:02:36, which means that the session is up and running for 14 hours and 2 minutes. If the state is not established, it indicates a problem with the BGP peering or configuration. But in this case, it's established, so it's good. Last read and last write show the last time a message was received from or sent to the neighbor. For example, last read 14:02:36, last write 14:02:36 means that the last message exchange was 14 hours and 2 minutes ago. So these values should be close to the current time and consistent with the keep alive interval. Message statistics show the number of messages sent and received from the neighbor, such as opens, notifications, updates, keep alives, etc. So for example, opens 2.2 means that 2 open messages were sent and received to establish the session. Updates 7.6 means that 7 update messages were sent and 6 were received to exchange routing information. So these values can help identify any message errors or mismatches between the peers. Prefix activity shows the number of prefixes or networks sent and received from the neighbor. For example, prefixes current 4.3 means that 4 prefixes were advertised to the neighbor and 3 prefixes were received from the neighbor. So these values can help verify if the expected routes are being exchanged or not. Local policy denied prefixes shows the number of prefixes that were denied by local policies such as route maps or filters. For example, local policy denied prefixes outbound, inbound, total, 00 means that no prefixes were denied by local policies in either direction. So these values can help troubleshoot any policy issues affecting route advertisement or acceptance. Alright, so let's try pinging PC4 from PC1 to confirm that the routers are sharing the routes with one another. Awesome. You've now connected your second set of autonomous systems together using BGP. Now save your packet tracer file and update your notes. Then write your narrative. After that, share the Google Drive folder you have for this lab with anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.